Hello, and welcome to PulumiUP. Really excited to have you here today to talk about universal infrastructure as code. We're going to talk about some exciting new product capabilities we launched just this morning. We're going to see some exciting code-centric demos and see some of what Pulumi customers in the community are building. Unbelievably, we just passed our 5-year anniversary as a company. We launched the open source project in 2018, and ever since then, we've had a constant stream of innovation with Pulumi 1.0 and then 2.0, which introduced superpowers, expanding beyond infrastructure as code into policy as code and testing. Pulumi 3.0 just last year with exciting new capabilities around new languages and component models. And today, universal infrastructure as code. And we'll talk about that a lot more throughout the remainder of this talk. But first, really want to celebrate some amazing momentum. You know, ever since we launched, community has been everything to us. Open source is where we start and where we end, and that's where we spend most of our time, is making sure that the community is successful. When the community is successful, Pulumi is successful, and that's the mindset that we've had from the outset. It's great to see so much contribution coming from the community. 2,400 contributors with over 35,000 pull requests, up over 12,000 GitHub stars. You know, just a lot of vibrancy and momentum there. In addition to that, we've seen incredible momentum in the partner ecosystem. And today, I'm really excited to announce some new partners, including Oracle Cloud, Elastic Cloud, Databricks, JFrog Artifactory, Event Store, Scaleway, Slack, Tailscale, TwinGate, Checkly, and BuildKite. These are all new packages you can use with Pulumi that are now available in the Pulumi registry. Of course, we've got over 100 other partners that are very important to us that we continue to deepen relationships with and help with shared customers and ensure success. That includes AWS, Microsoft, Google Cloud. It includes the Cloud Native Computing Foundation with Kubernetes and Helm and other projects that we support natively with Pulumi. It includes large enterprise partners like VMware and Cisco, and dozens of others of ISVs such as Cloudflare and Fastly that are helping with other parts of the cloud engineering ecosystem. CI/CD integrations with GitHub, GitLab, Atlassian, Octopus Deploy, Armory, Travis CI, and the list goes on. The partner ecosystem is vibrant and growing just as much as the open source ecosystem for us is. We've also seen a lot of customer momentum here, and we find that, you know, folks love using open source. We love, you know, our entire community, but, you know, we've seen a huge uptick in enterprise customers with over 350% year-over-year growth over the last year in enterprises adopting Pulumi. That includes Mercedes-Benz and Snowflake and Atlassian, but also, you know, some new customers showing up just more recently, including Facebook, Blue Nile, and BlockFi and Anisian. And all these customers doing amazing things with Pulumi, just really leveraging the cloud, empowering their developers to move faster, and empowering their infrastructure teams to do more with less. And, you know, Atlassian speaks to this point where, you know, they've reduced developer time spent on maintenance by 50%. That's incredible. They did this by giving developers access to infrastructure as code in Python. It's a language they're all familiar with. They're very productive with it. And that reduction of 50% means that, hey, 50% of their time is now freed up to go spend on adding customer value and customer innovation. And this is actually the Bitbucket team themselves who adopted Pulumi. So incredible story. And this is just one story of many that we're hearing coming from our community and our customer base. I think, you know, why are people adopting Pulumi? Well, you know, the modern cloud, there's a lot of challenges in how we adopt modern cloud. I think there's many reasons to embrace the cloud, you know, rich services and capabilities such as AI and ML services, infinite data scale, data warehouses, serverless capabilities where it's just much more cost effective than parking a virtual machine. The need to innovate faster and compete with new businesses. You know, we see that every industry is being transformed by software, and we don't build software like we did 20 years ago. All software is cloud software. And so really embracing the cloud is really important to staying competitive as a business in this modern world. Customers also have higher expectations. They expect, you know, new services and new products and you know, new capabilities, and everything's online, especially in this remote world. You know, the expectation is just increased that everything's available in the cloud these days. And, you know, the need for high scalability. You know, a lot of these services have to scale up from, you know, orders of magnitude from, you know, quiet times to peak load. And how do we do that? Well, the cloud is a great way to add that elasticity into our workloads. So those are all the reasons we might go to the cloud, but why are people struggling? Well, there's a lot of frustration when we talk with folks in the community and our customers, where developers aren't empowered to embrace the cloud in most cases, which means the feedback cycle is just a lot slower. The ability to incorporate modern cloud capabilities into the actual application's architecture is limited. You look at a serverless architecture that really impacts how you build your application. It's not an afterthought. It's a deep fundamental thing that you want to integrate into the inner development loop. And putting developers in the driver's seat is the quickest way to empower them to add value for your customers. But there's silos that divide, the fact that infrastructure, DSLs, and languages are very different from the developer tool stack just worsens this situation. We hear that infrastructure teams, on the other hand, are toiling away with languages and tools that just frankly aren't great compared to what we have in in developer land. A lot of copy and pasting of YAML, a lot of copy and pasting of domain-specific languages, and cloud leaders' expectations aren't met. Even if you succeed at going to the cloud, oftentimes the cost payoff might not be there. The team still can't move as fast as you wanted because of these prior 2 points. The silos are still there, and as a result, all of us are struggling to adopt a modern cloud. And I think why are we here? Well, I think we've gone through multiple major iterations of the cloud journey. We started with Cloud 1.0, which was really an on-prem model with virtual machines. We started virtualizing, and that was great for more dynamic deployment of workloads. We didn't have to rack and stack physical servers. So that was definitely an improvement, laid the foundation for everything to come. But applications were very monolithic. Maybe you'd have 2 virtual machines and a database. Very simple architecture. So that was sort of the Cloud 1.0 era. And by the way, we shipped once a quarter. It was very common to wait as a developer for up to a quarter to get a new virtual machine when you needed to scale up your workload. So the Cloud 2.0 era was a big improvement, which was moving virtual machines to the cloud, still mostly static, but starting to break apart the monoliths. Maybe we have N-tier applications. We increase the velocity of shipping from once a quarter to once a month, or maybe once a week. We had tens of services we were managing. It was still relatively tame in terms of the complexity. But then, we really accelerated as we went into the containers and serverless and in this modern cloud native era, which we'll call, Cloud 3.0, where we're actually assembling lots of building block services, including containers and serverless and managed services. Of course, virtual machines are still there in the picture for many of us. A lot of folks are doing hybrid, and that's okay. That's part of the Cloud 3.0 era. It's an important piece. But we're shipping a lot faster. We're shipping continuously, daily, potentially on every Git commit. And we've gone from tens of services to now hundreds or thousands of services. The complexity of the modern cloud is just enormous. And that requires a different approach. We need to move beyond copy and pasting scripts and copy and pasting DSLs to really software engineering. And so our tools really haven't kept up until now, where, with Pulumi, we're really excited to talk today about universal infrastructure as code. I think infrastructure as code is the way you manage all of the resources in the cloud. It gives you a programmable surface area that allows you to provision, scale up, scale down, and really program the cloud. And we're really excited about that. And to us, universal cuts across multiple dimensions. One is the cloud itself. I mentioned hybrid. Hybrid is a reality for virtually everybody doing something in the cloud. And what that means is you've got public, you've got private, you've got hybrid, you have great SaaS services like Snowflake that you might want to leverage as well. All of that is infrastructure and needs to be managed. And with Pulumi, with this universal approach, it gives you one workflow, one standard way of approaching the cloud. We're not trying to hide what makes each of the clouds, magical and different, but we are trying to give you one standard approach to all of them. Universal also means every language. We want to accommodate all different folks from infrastructure backgrounds, from developer backgrounds, and really make it much simpler to program the cloud and access the cloud. And to us, that means, we want to be in the language communities, meet people where they are, and bring the cloud closer to them. It means every builder. One of the reasons for the silos is we have different tools for infrastructure teams than we do developers. With Pulumi, we really see the world as we're all builders. We're trying to use the cloud. And we want one solution for all builders of all different backgrounds, whether you're an ops person, an infrastructure platform person, a developer, a full stack developer, a security engineer. Pulumi is the platform for you. It means every architecture. I mentioned virtual machines sitting alongside containers and serverless and managed services. And there's a lot of tools out there that are only for one of those particular points on the spectrum. We see a world where universal means all of those architectures. And similarly, every cloud resource. And so universal means no matter where you're coming from, we're going to help you get up and running on infrastructure as code. Pulumi supports lots of different languages, as mentioned, Node.js with TypeScript and JavaScript. We've got Python support, .NET support with C#, VB, F#, Go, and also Open Policy Agent for writing your policies. What that means is not just the language, but the entire ecosystem around that language. All the IDEs, you can use great editors, get refactoring support, statement completion, interactive documentation. You got great tools, test frameworks, package managers, but also all of these clouds. We've got over 80 cloud providers. Many of these already highlighted on, when we're talking about partners, every one of these is a partner of ours. We work together to make sure customers are successful. And then your way, which means if you're going to do CI/CD, we're not trying to replace your CI/CD system. We're going to integrate with whatever you've already got, whether that's GitHub Actions or Spinnaker, CodeFresh, Octopus. And so really we've taken this approach of integrating with the world of languages, clouds, and other tools that you might be using. You'll see a little bit of a blurry spot on the left. We've got some exciting news to talk about shortly, but we'll get to that momentarily. I think one key facet, since we're talking about infrastructure as code today, it's important to highlight that by using general purpose languages, you're not losing the benefits of declarative infrastructure as code. In fact, that's the magic of Pulumi, is you get both of these, they're better together. You get all the benefits of industry standard programming languages. They're expressive, familiar, user-friendly. You get these great tool support that I just highlighted. You get abstraction with sharing and reuse, testing, linters, and great communities. You've got each of these languages has millions of people in the community. You can find things on Stack Overflow. People graduate from college having learned these languages. So really betting on the industry's best programming languages is key. And yet we've taken that and given you everything you've got with declarative infrastructure as code. You can preview deployments before you make them, CI/CD integrations, full access to the entire cloud for all these cloud providers I mentioned, a history of who changed what and when, rich automation and workflows, and the ability to enforce security, compliance, policies, and best practices. And I'm really excited to announce today that we're introducing Java to the family of languages supported by Pulumi. It's available today. And what it means is you've got the full richness and expressiveness of Java and the ecosystem around it. So it's not just Java, it's the entire JVM. So any JVM language, which includes Scala, Clojure, Kotlin, and Groovy. And we've worked really hard to make sure that it's idiomatic and fits in with the entire ecosystem. So build tools, IDEs, package managers, test frameworks, everything just works. So if you want to use Maven and publish your packages on Maven repository, you can do that. If you're using Gradle, great. If you're using IntelliJ, wonderful, but you can use Eclipse too. So really the full breadth of the Java platform. And what that looks like is just writing normal Java. So you can crack open your favorite editor, write some Java, and it works with the existing Pulumi toolchain, just as you would expect. CLI, everything just works out of the box. And here's a fun example with Groovy, simpler, scripting-based language. And but rather than just looking at slides, I'd love to welcome Luke Hoban, CTO of Pulumi, to give a demo, and then we'll talk to Brian Getz, architect at Oracle, who works on Java, to hear his thoughts on the new Pulumi Java support. Welcome, Luke.
Thanks, Joe. It's great to be here and really excited to show off some of the new features we're doing, starting with Pulumi Java.
Awesome.
All right, well, to get started, we're going to lean really heavily into the infrastructure as code thing today, and we're going to spend a lot of time in code in our IDE environment, writing Pulumi code to manage cloud infrastructure. And so to begin with, let's start with a blank slate inside our IDE here. We're going to start with our Pulumi Java support. So we can run Pulumi new to create a new Pulumi project. And we actually see that as well as the existing languages that we support, like TypeScript and Python and JavaScript, Go, and C#, we now also support Java. And so let's go ahead and create a new Java project. And so we can name it PulumiUP Java Demo. We can keep the default description, go with the default stack, and go and deploy this into US East 1. So when we do this Pulumi new, we create a brand new Pulumi project, but in this case, deploying with Java and using AWS. And so just to give a quick tour of some of the core pieces of Pulumi from the Java perspective, we of course have our Pulumi YAML file, which describes that we're using the JVM as our runtime. And so our Pulumi program is written in Java here. We have a Maven project, and it has dependencies. So it uses our Pulumi library that we've now published on Maven Central, as well as our Pulumi AWS library for working with the AWS platform. Most importantly, though, we have our actual Java code. And so, for example, here we can say, we're going to create an S3 bucket in AWS, and we're going to export the bucket's name. So we see here, we're just using normal Java APIs to do this. And so, for example, here we create a bucket, and here we specify that we're going to get the bucket's name and output it. And so we can run just PulumiUP, the typical Pulumi CLI, to deploy this cloud infrastructure that's authored in Java. And while we wait for that to continue to deploy, well, I'll just go ahead and say yes to actually deploy that bucket. Now, because we're in an IDE here, we can actually get all the features of our IDE. And so, for example, within the AWS namespace, I can see all the things that are available. And so it's not just the S3 bucket that we're working with here. It's dozens and dozens of different features of the AWS platform that are available and projected into our Pulumi experience. And so, for example, I can go into EC2 and look at all the different features of the EC2 platform that are available to me now from within my Java APIs. And so all of the sort of hundreds and hundreds of APIs from within the AWS platform are projected now into Java APIs. And that's true for AWS, but also for the 80 or so other providers that we have available for Pulumi. I can also go ahead and use the Java APIs that we support to specify additional properties. So for example, if I want to make some changes here, I can say I want to pass in some bucket args. I can use my IntelliSense to go create that, and I can go and use the builder pattern to actually create the properties I want to pass to this. With that, I get access to all the different properties of the bucket. And so I can specify any of the different properties I want to specify. So I could specify the ACL on this to something that's not the default private. Or I could specify, for example, the website and specify the bucket website args and keep on going from there. What I'll do is I'll just actually jump over to a slightly more complete version of this. It shows a handful of additional features in progress here. And so here we see that bucket where we specified the website and specified an index document. And then we've also used some Java language features to take advantage of using the Java language as part of our infrastructure as code definition. And so in this case, we've done a few things. We're using some control flow in the Java language, like some for loops and some try-catch statements. We're also using built-in features of the Java platform, like the ability to read files off of disk, list what's in a folder. And for each one of those files that's in this folder here, we're actually going to create a bucket object and specify some properties, including that we'll use the content of that file as the content of our S3 bucket object. So this is a very simple piece of infrastructure. It's going to stand up a bucket and stand up the ability to deploy some resources within that bucket. When I go ahead and do a PulumiUP here, we'll actually see some of the things that Joe was talking about in terms of this being the best of both worlds for being able to have imperative program, but still desired state infrastructure as code. And so we don't have to recreate that bucket. We already created that with our previous update. Here, we're just going to update it, add in that website property, and then we're going to also create the new bucket object that we need to specify. We can see the details of that diff, exactly what's going to change our infrastructure. We get this preview so we know what's going to change before we do it. And if we like what we see, we can go ahead and say yes to deploy that to the cloud. Okay, there we go. We're updating our bucket, and we're going to also deploy the bucket object. We now get the URL out here, and so I can do something like just grab this and say, open that URL, and there we go. We've got that file stored now in a bucket. It's up in S3. We've deployed some real cloud infrastructure from our Java code. Now, one of the really nice things about using programming languages is, some of this control flow, some of the libraries are really nice. What's even nicer is the ability to create reusable abstractions. And so, for example, in this case, we've created a simple abstraction called sync files that lets us do that same thing, but using a simpler API. And so this is something that I can go and, instead of copy pasting my infrastructure all over the place, I can go and give this set of abstractions a name, this for loop that uploads bucket objects into this bucket. And here is, I've defined that in some code, just in another file here. And this is a simple Java class that has that same code we just looked at inside it, but that implements the Pulumi custom resource base class, which allows me to sort of use all the features of Pulumi, but in a reusable component. And this is a really important capability that allows us to really reuse code within our project and then share that across other projects as well. Of course, once we've put our code into a reusable component like this, we can also now test this. So we could go take our favorite unit testing frameworks in Java and apply them to this component to make sure that this component behaves as we want, and then test that in isolation so that when we go and use it in other places, it works as we expect. Now, in this example, we looked at AWS and just one simple resource with S3 buckets inside AWS. Of course, Pulumi Java supports everything that's available inside the Pulumi registry. And so that includes all 89 or so packages that we have here, from our new Oracle Cloud provider that Joe talked about to our providers for our major platforms with AWS, Azure, Google Cloud, and Kubernetes. Let's take a look at one additional example here of doing this with Kubernetes and Java. Okay, so to see this, we can look at an example of working with Google Cloud and Kubernetes. And so this is a much more complex example written in Java and using multiple of our cloud providers. And this example shows off a few additional features. So for example, from our Java code, we can access Pulumi configuration to allow users to specify when they deploy this stack, what is the master version I want to specify? And if not specified, we'll go and get the engine versions and just use whatever the latest version that GKE supports is. We can then go ahead and create a GKE cluster. We can go ahead and create a GKE node pool. And then we can use that node pool and cluster to actually create a kube config using Java code that specifies how do I connect up to this GKE cluster from Kubernetes. Of course, Pulumi also supports a Kubernetes provider, and so we can construct one of those and use it to connect up to this new cluster we've created, and then use that to specify some additional resources. So here we're going to specify a Kubernetes namespace, a Kubernetes deployment, and a Kubernetes service, all from within our Java code, and all using the APIs that we've just shown how to use. This example shows that we can build very rich things using a combination of all the features of Java plus all the libraries that are available from Pulumi. And we can use those to specify complex infrastructure and chain things between these different providers. Now, this kind of complex code, just like we saw before, we often are going to want to take these pieces and turn them into reusable components that we can use in other places. And so, for example, one of the components that we have available for Pulumi is actually an Amazon EKS component, which takes a similar pattern applied to the Amazon Elastic Containers Kubernetes service and makes it really easy to deploy Kubernetes on AWS with just a few lines of code. And this, unlike some of the other providers we have, this is a component, which means it's a piece of code written in Pulumi, not a thing provided directly by the cloud provider. And in this case, it's a component written in TypeScript that makes it really easy to work with EKS. And so we can see an example of using that from Java here, where unlike the previous example, which was 200 or so lines of code and a lot more kind of complex infrastructure, here we've hidden all that complexity away behind a simple abstraction by using this Pulumi EKS cluster. And here we specify just a few properties, the instance type, the min size, and the max size, and then we can get out the kube config. And so just to give you a feeling for what this looks like, we won't go ahead and deploy this because it'll take 8 minutes or so. But if I do a Pulumi preview, we can actually see what Pulumi will deploy from this simple program. And we see that it doesn't just deploy this EKS cluster. It deploys all the different resources that we need to stand up a best practices EKS cluster. That includes, obviously, the underlying AWS EKS cluster, but it also includes things like the roles and the security groups and the launch configuration, and even the config map inside the Kubernetes cluster that we need to manage the nodes. And so this simple program, I get to use these higher level abstractions that are available from within Pulumi. Now, all these examples so far have been in VS Code, but we can, of course, also come in to other IDEs like IntelliJ in this case, and get all the nice rich features that they offer, from really nice IntelliSense to the ability to, if I make an error, I get nice highlighting on that, and the ability to get really simple code completion within my code. Of course, when we're in IntelliJ, we can also take advantage of things like IntelliJ's ability to convert Java files to Kotlin. And so Joe talked about how we have access not just to Java, but to all JVM languages. And so, for example, if we go ahead and convert this into Kotlin, we can see that now we're able to continue coding against the exact same APIs available for the JVM, but using the control flow constructs, and the expressions that are available within the Kotlin language. And so access to really everything that's available from the Java ecosystem, now connected up into the powerful cloud capabilities to program the cloud using Pulumi.
Wow, that was a great demo. Awesome to see Pulumi and Java in action together. And to go deeper on Java and why we're so excited to bring Java support to Pulumi and the ecosystem, I'd like to welcome Brian Getz, Java language architect at Oracle. Hello, Brian.
Hey, Joe, how are you?
I'm great. How are you? Would you like to introduce yourself to the audience?
Yeah. So I'm Brian Getz. I'm the language architect for Java, which means I have the amazing job of charting the direction of the Java programming model over the next decade, which is lots of fun.
Yes, I can imagine. And what did you think of the demo, Brian?
So I mean, I thought it was great. I mean, obviously, I like anything that makes it easier to program with Java in the cloud and deploy to Oracle Cloud. But if I hadn't seen the list of languages that are supported in the demo, you might have been able to fool me into thinking that this was just a Java tool. It looks like a Java program. It uses all the modern Java API idioms, and it looks like an awfully pleasant way to build an application configuration.
Well, definitely coming from you, that means a lot. The team has been hard at work at this, and every language we bring up, we try our best to be as idiomatic as possible. And so it's wonderful to hear that you think we've succeeded at that.
It looks awesome.
I remember a few years ago, before we actually launched Pulumi, I was talking with you at a conference. I think it was QCon London, maybe, and I was telling you about the idea. And the idea of doing infrastructure as code in your favorite languages versus, say, an infrastructure-specific DSL just really resonated with you. I'm curious if you could talk a little bit about why.
Yeah, absolutely. There are a couple of reasons. One is the infrastructure as DSL tools are really not that great, right? They always have this bolted onto the side feeling. And the reality is that your application configuration and infrastructure is part of your program, and it should be part of your programming model. And if you have to build a program that is split across multiple programming models, things always fall in between the cracks, right? And we see this in the gap between our program and our build tools or our configuration tools, where we have to make things agree on both sides, and there's plenty of opportunities for mistakes, and you end up using multiple different tools with multiple different paradigms. And the more that you can bring into the programming model with, your favorite language, and, Java is a statically typed language. So I love that you're bringing strong statically typed, strong static typing to application configuration. It just makes everything more seamless.
It's interesting. I think with modern cloud architectures in particular, it used to be the case that we'd have a couple virtual machines and a database, and maybe it was okay to have completely separate config languages. These days, modern cloud architectures just have so much, so many moving pieces, and with serverless and containers, really, the infrastructure comes a lot closer to the application code. And in that world, having a separate config language just really doesn't make sense anymore.
Absolutely. And a lot of the config languages are pretty terrible languages as programming languages, right? They lack the basic tools for abstraction and reuse and tooling for navigation, IDE support, all of those things. And as you say, if you build your application out of 2 or 3 components, then having a script written in your favorite scripting language is just fine. But if you really want, if you're actively developing your application and it's actively changing, you want to be able to co-maintain your configuration with your application, and you need a real programming language for that.
Yeah, it is funny. I think the three of us have been working on programming languages for quite a while, and DSLs always have a tendency to grow up into general purpose languages, whether you intended for it to happen or not. And in hindsight, you often would have done things differently once you get there.
Absolutely. I mean, they often grow up into terrible programming languages, because not only are you constrained by some relatively rigid format like XML or YAML or whatever, the programming language features are often incrementally nailed on the side. So someone comes up with the idea of, oh, we need a loop construct. Oh, we need a conditional construct. And if these things aren't co-designed, they're going to have odd variances with each other that makes it that much less fun to program in.
Yeah, and I'm curious, I spent a lot of years, working on Java, although the language has come a long way since then. I probably, haven't really done much with, generics and lambdas and some of the modern innovations. And I know Luke spent a lot of time working on JavaScript. I'm not sure how much, Luke himself, until we're bringing up Java, has spent in the ecosystem. I'm curious, Luke, what are your thoughts, and do you have any topics for Brian today?
Yeah, well, I guess, one of the questions I have for you, obviously Java's evolved a ton in the last, 10 years or so. And I imagine, over the last few years, there's been a huge amount of growth in the language. And I imagine that the cloud has played a part in that as developers are, using Java or sort of deploying more and more into cloud environments. How do you think about kind of how Java is growing as a language for the cloud?
Yeah, so one of the things that is that makes this job continually interesting is that the things people want to do with their programming languages is evolving over time, right? And so we're in the middle of this migration from having built these monoliths to having built more loosely coupled applications that are built out of services. And what that means is, one of the things that means is the size of any given programming unit is smaller. And that means that more of the code is closer to the boundary and more likely to be dealing with data that's coming in from the outside world, not as a serialized Java object, the way it was back in the Java EE days, but as a JSON document or a SQL result set or something like that. And even if it's coming from a place that has data types, they're not necessarily the same data types as Java has. They may not have the same range for integers. And so, you don't want to have big, expensive code at the boundary to, translate from these formats, because that will overwhelm your actual business code. And so one of the things that we've embraced is a sort of more data-oriented programming, and features like records and seal types and pattern matching make it much easier to sort of define the boundary between your code and the untyped, messy real-world code in a flexible and relatively lightweight way. And I think that's going to allow you to have Java participate in applications that might, not just be pure Java, but maybe a mix of various things, and still get all the benefits of Java without paying this huge tax of, okay, now the data is coming from this other untyped language into Java, and I have to do something about it.
Yeah, that really resonates with me. The infrastructure side is difficult, and infrastructure as code is one key component, but there's the application logic, the need to build these finer grained services, even sometimes down to the individual function as a unit of deployment. And that really changes the way you think about data, connectivity, concurrency. One of my favorite books on my shelf back here is your book, Brian, Concurrency in Practice. There's a new kind of concurrency that people have to worry about. It's not shared memory concurrency, really. It's sort of this more distributed programming architecture. And I know a lot of the future, you mentioned your role is to invent the future for Java. And can you talk a little bit about, what's on the horizon? What isn't solved yet? What are some of the challenges you're facing?
Yeah, I mean, how much time do we have? Geez, there is so much yet to do, right? So, one of the things that's really exciting about what's coming up soon is Project Loom, which is sort of rebuilding the concurrency model for Java by not rebuilding the concurrency model for Java, right? So for the longest time, everyone thought, oh, you should do async await, or you should do a reactive library, and we thought really hard about it, and we realized that the programming model, with that Java gives you with threads is actually pretty good, and it gives you nice serviceability and stack traces and all of that good stuff, and code you can read. But unfortunately, if you delegate management of threads to your operating system, threads are pretty expensive, and you can only have a couple thousand of them, and that puts a limit on scalability. And basically, we rebuilt the thread implementation from the ground up, where thread stacks can live in the garbage collected heap, and you can now quite easily have 1 million threads running on commodity desktop system, and still get the full benefit of the Java sequential threading model with all the tooling and all the serviceability and everything. It's great.
Yeah, that sounds amazing. It's interesting. You look back the concurrency models in the 2000s, with task parallelism and async await, and just a few targeted changes to the language and the runtime really did change the game by an order of magnitude.
Yeah, absolutely.
I feel like we could be talking for days here, and I look forward to seeing you at a real in-person conference sometime soon. But for now, I think why don't we wind it down? Thank you, Brian, so much. And Luke, please stick around. We've got more demos to come.
Thanks a lot. This was great.
So we've seen why using general purpose languages is so powerful from an infrastructure as code standpoint, really giving you the full power of the cloud at your fingertips, full programmability, great productivity. But we're going to take things a little bit of a different direction for a moment here. We definitely know that infrastructure as code runs a full spectrum of simple use cases to very complex use cases. And being universal means that as Pulumi, we want to have a solution for all points along that spectrum. And there are three kind of use cases where maybe a full programming language might not be the first thing to pull out of your tool belt. First is those simple cases. Maybe there's just 1 or 2, 3 resources you need to configure. Maybe you're code generating some IEC, and code generating a full language like JavaScript is always complicated, especially if you have to parse it afterwards. So that's the first case, the simple use case. The second is, not every operator is an expert in programming languages or has an engineering background. We've certainly heard a ton of amazing success stories of folks with IT and ops backgrounds deciding to learn Python, really up-leveling their skill set in their career, and really investing in themselves. We love seeing that, but we know, taking a pause to go learn a full programming language isn't always top of mind for folks and isn't necessarily the next thing to reach for when you're trying to do infrastructure as code. And then the third is, ironically, not every application developer really wants to go deep in the full programmability of infrastructure as code. Maybe they'll get there eventually when they realize the benefits of bringing cloud architectures closer to their applications, but they're not infrastructure experts. They want a simpler approach for infrastructure as code. And we see, YAML is very common in the industry. It's sort of an industry standard. You look at Kubernetes, is all, all about YAML. CloudFormation from AWS uses YAML. I mean, there's a lot of YAML in the world. In many cases, it's a problem because people bend and twist YAML to do things that it was never intended to do. But it's an industry standard. We see, what can happen when people try to solve the complexity problems with YAML with, things like Helm embedding Go templates. And this has led to domain-specific languages like HashiCorp Configuration Language, HCL, which is a proprietary language that HashiCorp has created for their infrastructure as code tool, Terraform. Unfortunate thing about that approach is, at least you're not jamming Go templates into YAML, but you also run into issues where you've got to create IDE support. You saw all the things that Luke showed with Java. We as Pulumi didn't have to go build all that support. We're just tapping into all of that great innovation in the community. By going and doing a DSL, somebody has to go recreate everything, from IDEs to package managers to test frameworks, a very long list. We love getting all those things, being able to stand on the shoulders of giants by tapping into programming languages. So we've taken a different approach to how do we solve for the entire spectrum of infrastructure as code. And today I'm really excited to announce Pulumi support for YAML. And remember, the L in YAML stands for language. Really, YAML is just another programming language to us. It's another way to access the entirety of the Pulumi ecosystem. You can express your infrastructure as code in a simple YAML file, and you get all of the features of Pulumi. You can access all of the different cloud providers we talked about earlier, those 80+ cloud providers. You can even access components written in other languages. So if your infrastructure platform team is creating components in Go and publishing them, you can easily consume them from YAML, very simple format. This really helps to bridge the dev and ops divide. We find that this helps to round out Pulumi support so that we support all the way from very simple data format, YAML, all the way up to the most capable, most popular programming languages in the industry. And this allows you to scale up as you need. You can even start with the YAML and eject out of it as you hit the wall on complexity. So maybe you started with the YAML because you had a simple architecture, but now you've refactored it. It's gotten more complicated over time. You're starting to think about, I could use a for loop here or a function or some abstraction. The Pulumi convert command actually just takes your YAML and converts it to whatever language you want. Maybe you want to go to Java next, or maybe it's Python. full support for the entirety of the Pulumi language ecosystem to convert out of YAML when you hit that phase where maybe you've outgrown the needs of YAML. One last thing to highlight here is, because we're using an industry standard, YAML, it's not a proprietary DSL, we get all the benefits of that ecosystem. And one in particular that we're really excited about is Q language. The Q language is a templating language on top of YAML. It's sort of in between on the spectrum of YAML to a full-blown language. So perhaps instead of converting out when you get to the need for some templating or more sophistication, maybe you can reach for Q or one of the many other industry standard YAML-based tools out there. And so really embracing where the community is and helping to bring simpler infrastructure as code. To us, that's a key component of being universal infrastructure as code. And to see it in action, I'd love to invite Luke back on stage and fire up that editor and see some YAML.
All right, really excited to be back to show off our Pulumi YAML support. So as Joe mentioned, really with our YAML support, we're going to the opposite extreme here, really trying to be the simplest possible interface to the entirety of the Pulumi platform. And so what we're going to do is start with a completely blank slate. So we've got nothing here at all. We'll just go ahead and create a Pulumi YAML file, and we'll open that up. Within our Pulumi YAML file, just like we saw in our Java demo, every project in Pulumi has a Pulumi YAML file. It has a simple name like YAML demo, and it has a runtime. And so in the last demo, that was we're going to use the Java platform. In this demo, it's going to be I'm going to specify YAML. And so when we specify YAML as the runtime version for a Pulumi YAML file, it means that we can actually start to specify things in line inside the Pulumi YAML file instead of specifying them in code in another language. And so in this case, we're going to specify our resources. So we're going to specify one a bucket resource, and we want its type to be AWS S3 bucket. As well as specifying resources, we can specify outputs. And so in this case, I'll just specify the bucket name and say I want it to be the bucket's ID. Now, just like with any other Pulumi program, we can use the Pulumi CLI to deploy this infrastructure. And so in this case, we deploy the bucket. We go ahead and say yes, and that deploys the bucket out into AWS. Okay, so just like we saw though with the Java example, we can specify additional properties. And so for example, here we might want to specify that website property, which has an index document. We're going to specify that's going to be index.html. We might also want to grab some additional code, and I won't type this all in. I'll just copy paste it so that we can move a little bit faster here. And this allows me to specify an additional resource of an index.html file that I'm going to upload as a bucket object, just like we saw in the Java demo. Just like we did in the outputs, we can also reference the bucket as an input to our bucket object by specifying the $curly. And this is a simple interpolation that lets us take the value of some output of resource and use it as an input to another resource. We'll go ahead and say PulumiUP, and we go ahead exactly the same way, desired state infrastructure as code. I'm going to update my existing bucket. I'm going to create this bucket object. Okay, so very simple code. You can do all the same things that we could imagine kind of from that Java demo, but now just using this interface of a simple YAML file. Now, this is a really simple example, but we can also do a few other things. So for example, I might want to specify a Kubernetes pod. And so we have a Kubernetes provider, so I can specify, Kubernetes v1, core v1 pod. And the interesting thing about this is that because YAML is the sort of lingua franca of Kubernetes, I can actually come over into a site like this where I've specified, where I find a few examples of kind of pods in Kubernetes. I can go ahead and grab this text and just specify it right in line here. Actually, I just got to specify the properties. Because it's just YAML, I can literally copy paste this in. Go ahead and do PulumiUP. We'll see the PulumiUP here will actually say it's going to remove the bucket and bucket object and create the v1 pod. So let me go ahead and do that. We're actually going to create a Kubernetes pod in my local Kubernetes environment and then clean up the resources we no longer need. I can go ahead and say kubectl get pods and see that exactly that pod that I just specified in that code that I copy pasted is available here. Now, this is just YAML, so I can just copy paste it from Kubernetes. But of course, I can also means I can sort of reference things that I might have defined somewhere else. So if I had the name of this image as Pulumi configuration, I could use Pulumi to coordinate that. If I wanted to take the output of my pod, like the pod's identity, and use that in another resource, I could easily do that. And so we can use all of Pulumi's engine's ability to do deployment orchestration, along with the ability to specify things in this YAML format. Now, there's one additional sort of example that is maybe interesting to show, and that is, Joe talked about the ability to sort of use components built with other programming languages, with TypeScript or Java or Go or any other language available in the Pulumi ecosystem. We can build reusable components, put them in the registry or define them for use within our organization, and then consume them from our YAML code. And this makes it so that YAML can be a very simple interface where all the complexity gets pushed into other places. And so, for example, here, we're going to have the EKS cluster. If I just do a simple PulumiUP right here, we'll see that oh, I didn't save my file. Well, let me do a PulumiUP. And we'll actually see that even though I just specify this single line of code for the cluster, just like in the Java demo, this is going to create many resources. Well, I need to specify the region as well, but just like in the Java demo, this creates many resources. Okay, so this is a very simple, all these examples have just been a few lines of code. But of course, you can build more complex applications with the Pulumi YAML support. And so here's an example that shows off a few additional features of Pulumi's YAML support. So we saw resources and we saw outputs. We can also use configuration and variables. And so for configuration, we can specify those Pulumi config that we can set via the Pulumi command line. And here we specify that we use a SQL admin configuration setting, which has the default value of Pulumi. We can also specify variables. And these are names that are going to be bound to the results of making calls into the cloud provider to get information out and use it within our resources. And so, for example, call Azure's get shared keys and Azure's list registry credentials. Within our Azure program, we can, of course, do a lot of the more complex things that you can do with Pulumi, but all through this YAML interface as well. So we can specify things like our resource group. We can use that resource group to create a kube environment. We can create an Azure container registry instance. And we can use that container registry to then work with our Docker provider to build and push an image to that registry, and then use that image from within a container app in Azure. So complex coordination across multiple providers, all with this very simple kind of interface. I won't show deploying this example because it'll take a while, but it's an example of how I can sort of build these more complex things. But of course, if I can build these more complex things, YAML can become difficult to manage once we get to scale. And so there's a few ways that we approach how you manage scale for these YAML projects. The first is, of course, because it's YAML, we can code generate this from other languages or code generate this on the fly from programmatic interfaces. And that creates a whole bunch of new opportunities for how you interface with Pulumi via this as a programmatic target. One example of that is Q. And so a bunch of different languages that compile down to YAML, Q gaining a lot of popularity in some parts of the space. And Q is sort of a layer on top of YAML or JSON or any of these formats, which lets me introduce some additional concepts. Like they have reusable components that I can specify, like the static web app. They have the ability to have a simple type system that can do some type checking over my YAML files, and the ability to specify defaults and structs and that sort of thing. I can then use that to take my reusable component and instantiate it twice as the resources. And so, for example, if I run this, I can run my Q tool to compile this down into YAML. And then I can come over here and say PulumiUP to deploy this. And here we go. It's going to deploy 2 copies of all these different resources because I instantiated my thing twice. Now, if I want to really take advantage of all the benefits of Pulumi as I scale up the complexity of my infrastructure, I can also go and convert my Pulumi programs right back into something that works in any of my existing Pulumi languages. And so if I take this project as I specified it before, let me go back into that folder, I can actually also run Pulumi convert. So I can run Pulumi convert, say I want to convert it to Python, and specify that I want to put it into this other folder. So there we go, I'm going to convert that and come over to this folder and see that what I generated was actually a Python file that has the exact same definitions as my existing YAML project. And in fact, I can go ahead and continue to develop from here. I can write tests using my test framework of choice. I can use for loops, I can use abstractions, all those software engineering benefits. And I didn't get stuck kind of at the limits of what YAML can support. I have a natural off-ramp onto proper software engineering practices available inside richer Pulumi languages. And so that's a great summary of kind of the Pulumi YAML support from really simple programs to more complex things, and then the ability to ultimately eject out into any of Pulumi's existing languages.
Well, wow, that was super cool. I have to admit, I'm really excited to be launching YAML. That's probably not something that most people would expect for me to say, but you can see all the power and capability of the Pulumi platform just shining through with a simpler interface, the ability to grow up as needed. Really, Pulumi is the first universal infrastructure as code tool that supports any cloud and supports YAML and the full spectrum of programming languages. We think it's just a combination made in heaven. So super excited to be launching that today. And we're talking a lot about infrastructure as code, but it's really important to realize that everything we're talking about integrates with the Pulumi Cloud Engineering Platform, which enables teams to adopt infrastructure as code and go beyond that. I wanted to highlight a few key capabilities of the infrastructure, the way that Cloud Engineering Platform works, including we've got Pulumi Crosscode, which is our policy as code engine, supports lots of different languages for authoring policies, including OPA, the Open Policy Agent. We've got test frameworks and integration testing so that you can do continuous verification as you're delivering your infrastructure, whether that's testing your application code, testing your infrastructure code, testing that ephemeral environments are actually functioning before you do deployments. A lot of richness and capabilities there. Got all these CI/CD integrations so that hey, it's a great developer desktop experience, as you've been seeing with the demos Luke has been giving. But when it comes time to go to production, you can have secure pipelines and really put your production environments under lock and key and actually really harden the delivery process and unify how you deliver applications and infrastructure to scale from one environment to 10 environments. Some Pulumi customers are managing tens of thousands of environments using this approach. And so it's important to point out there. Of course, secrets management is built into Pulumi. It's not bolted on as an afterthought. So if you've got sensitive information in your config, you've got a way to do that out of the box. Role-based access control, integrated identity, policy enforcement at the server side, a lot of great capabilities that enterprises need to operationalize infrastructure as code. And from there, we're going to talk a little bit about Crosscode. We haven't talked much about Crosscode, but this has been in the works for over 2 years now. And Crosscode really is the secret sauce to making the Pulumi magic work. Crosscode is how we've been able to support the entire platform across all of these languages and to deliver it in an idiomatic way. We'll talk about a few of the key capabilities, and we'll talk about some sharing and reuse and get back to some more demos with Luke shortly. I think one key capability of Crosscode that it gives us is universal translation. If you're starting from somewhere else, which we know a lot of people are, you might have used Terraform and in the past, you might have used CloudFormation, you might have some Kubernetes YAML, ARM templates, you might have manually pointed and clicked in the console, which is a fine way to get started. It's an easy way to explore and understand what the cloud has to offer. But now you're ready to move to a universal infrastructure as code platform, i.e., Pulumi. And we've got a few ways to do that thanks to Crosscode. You can translate existing infrastructure. We have a TF to Pulumi tool, an ARM to Pulumi tool. You actually go to Pulumi.com, and we have these both in command line form and a hosted website version to do this conversion. You can actually import existing resources. And this is really mind-blowingly cool. The Pulumi import command, which we have completely overhauled. We had a different version before. Now we've hooked it up to Crosscode, and it actually generates the infrastructure as code that would have produced resource state that already exists in the cloud. So if you went into the console, you spun up some resources, you can actually run Pulumi import, give it the ID, and it's going to spit out code in your favorite language, Java, YAML, Python, any of the existing languages. And then you can take that, and from there, you're fully on infrastructure as code. Really helps to onboard, no matter where you're coming from, we've got a solution to help you get up and running on Pulumi. Crosscode is also the way that we have cross-language sharing and reuse. We launched the Pulumi registry last year and the package model, and Crosscode is enabling us to write in any language and consume in any other. You saw this in action in Luke's demo. The EKS cluster is one example of a package that's written in a language, but you can consume it in any other language. And we saw that you can do that from YAML, you can do it from Java. And the reason why on day one we have support for all of this is thanks to Crosscode. And of course, we support all the native package managers as well. So speaking of package management and building abstractions, I wanted to speak a moment about going from building blocks to architectures. One of the key things with Pulumi is we support over 80 different cloud providers, and we give you the full capabilities of the underlying resources, every property on those resources. We really want to get out of your way and just expose the entirety of the cloud in a programmable fashion so you can use it from infrastructure as code. This gives you amazing control, amazing capabilities. The thing that I love about this, and this is really the way the AWS platform was built, is you have all these capable building blocks and you can stitch them together in infinite ways to build new architectures. But sometimes that can be the daunting part, is trying to figure out how do these things fit together. And frankly, after your 30th time stitching together all of the things that constitute a virtual private cloud or an EKS cluster, it starts to get a little tedious, and that's where abstraction and sharing and reuse and encapsulation come into the picture. We can build libraries, we can build entire frameworks on top of that and really deliver great productivity with best practices built in. Pulumi Crosswalk for AWS, we launched a couple of years ago. It's great. It has a lot of these well-architected patterns and practices out of the box. I mentioned VPCs and EKS. It's got great abstractions for those, but also API Gateway, Lambda, CloudWatch, IAM, load balancing, ECS, if you're using the native container service. A lot of great patterns so that you can benefit from tried and true best practices. And this has been built with customers and the community. It really does reflect the common best practices that you would want by default out of the box. And we're really excited today to announce that Crosswalk for AWS is now available in all languages. Originally, we launched this as TypeScript only, but thanks to Crosscode, we're now able to deliver Crosswalk for AWS in all languages. Another exciting thing that we've done and are launching today is we've actually implemented support for AWS CDK on Pulumi. Many folks may be familiar with Amazon's Cloud Development Kit. It takes high-level languages and transpiles them into CloudFormation YAML that you can then go take and deploy through CloudFormation. CDK offers something called constructs, very similar to Pulumi components. Constructs are classes that encapsulate common patterns, and the AWS teams themselves, along with the community, have built up a library of constructs. And those are written in TypeScript and available in other languages. And what we've done is we've actually taken those constructs and made them work on top of Pulumi. So over 1,000 different constructs that represent additional best practices and patterns can now be run on top of Pulumi. The great thing about this is it's not deployed through CloudFormation. So it's not transpiling to YAML like CDK typically is. In fact, some of our early adopters have said they actually prefer using AWS CDK on Pulumi to the native CDK itself because deployment is all orchestrated through the Pulumi engine. In fact, you can mix and match. You can use a little CDK here, some Pulumi Crosswalk over here, some Kubernetes resources, some Azure resources, all in the same project. And by the way, that slide with the cloud engineering platform, you're benefiting from all of that at the same time. So policy as code is running against your CDK constructs. You can do CI/CD. All of the Pulumi platform is now available with CDK running on top. And to see some of these sharing and reuse and abstractions and something we like to call infrastructure as software in action, I'd love to welcome Luke back for another amazing demo.
So in the last few demos, we've really seen how we can sort of take new programming languages and access the entire richness of the platform. But over the last 6 months or so, we've also been working hard on expanding the richness of the platform and what you have access to from all of the Pulumi languages. And so in this last demo, I want to highlight some of the new things that we've added that are access to different capabilities in the cloud. So in the registry, since we launched this last fall, we've added dozens of new packages, and I'll just highlight a couple of interesting new ones. One, we added the command package. This has been one of our fastest adopted new packages. Opens up a whole bunch of interesting use cases for access and running local and remote commands. So remote provisioning of EC2 instances, all sorts of interesting things that are being unblocked and enabled by this provider. We've also added lots of new cloud providers and SaaS providers working with various partners. And so working with our partners at Elastic, added support for Elastic Cloud. Very easy to work with the cloud version of Elastic from within a Pulumi program and to coordinate that along with your other cloud infrastructure. Now today, we're actually also launching our own new package, which is a provider for the Pulumi service itself. So Joe talked about the cloud engineering platform that we offer through the Pulumi service. And we've had, obviously, Pulumi users are big believers in IAC. They want to be able to manage all the SaaS and cloud platforms they have from infrastructure as code. And so with this new provider, we give folks access to actually using Pulumi to manage the Pulumi service. And so let's start by taking a look at that in action. So I can come over here into my code and just say Pulumi service dot and see that I can access a handful of the different capabilities of the Pulumi service from directly within my infrastructure as code. So I can manage teams. What are the teams? What stacks do they have access to? What users are available in each one? I can programmatically provision and deprovision access tokens. And I can create webhooks for delivery when I make updates to my infrastructure. I want to get notified and be able to handle those. And so to see what that one looks like in practice, let me just say, const webhook equals new webhook. We can see I could specify just a handful of properties on this. I want it to be active. I want the organization name to be my organization upstarts. I want the display name to just be, Pulumi, since we're using Pulumi to manage Pulumi. And then the last thing I then need to specify a payload URL. And this is where do I want to send the webhook? And of course, I could go and provision some infrastructure somewhere else to define a handler for these things. But of course, one of the things that's awesome about Pulumi is that it's really good at provisioning infrastructure for other use cases. And so, for example, here, I can just use AWS X to create an API gateway that handles post requests to the root and then just prints out what it sees. And so now I can just hook those two things up and say I want to deliver the webhooks to that URL. Come down here and just say PulumiUP and deploy this piece of infrastructure. Right, and so we see it's going to actually deploy 18 resources, including that Pulumi service webhook, but also a handful of other resources to define the API gateway and all the compute needed to run that. So we're going to see it's going to take a couple of seconds to actually deploy this. But one of the interesting things we can do also is click on this link here to go into the Pulumi service and see a little bit more information about the stack. So this gives us access to all the features of that Pulumi cloud engineering platform. I can see the update deploying just as I would from the CLI, but now stored inside the service. I can see the various resources that are being managed here. And so I can see all the different things that are so far available. Some of them are still provisioning, so they're not listed here yet. And of course, I can also go see what webhooks I have provisioned. And so for my upstarts organization, I can come over to settings, look at integrations, and I can see that I have this Pulumi webhook already set up that I just specified in my infrastructure program. Now, the interesting thing is if I actually click on this, I can see that we already have delivered a notification, a webhook to that a few seconds ago. And that's because the update that created that webhook actually itself was an update that needed to get sent to the webhook. And so we've already actually invoked the same webhook by running that thing. So this is sort of an inception. The update triggered a webhook that ran and hit the endpoint provided by the update. And so if we do logs, we actually see that within my Lambda, that I implemented here, I actually got logged that output, and I can even come back here and see which update it was that triggered the webhook. So really kind of cool that I can combine managing the Pulumi service with these other capabilities. Now, we saw here using AWS X, and as Joe mentioned, AWS X is now available in all of the Pulumi programming languages. So we can take a look at that in this example here. So AWS X offers best practices patterns for AWS for a number of different building block services, but one of the most popular is actually working with ECS and Fargate. ECS and Fargate are rich services for just running containers in a really simple way using AWS. But the interface to them from infrastructure as code is somewhat complex in terms of the raw building blocks. You have to use all the features of load balancing and all the features of Fargate services and task definitions and all the different pieces involved in that. And so with AWS X, we give a really simple interface to that with just a few lines of code, you can build really simple applications that deploy containerized applications to AWS. In this case, we just say we want an application load balancer. We want it to load balance on port 80. And then we want to specify a Fargate service that's going to run the Nginx image with a bit of memory, targeting the container port and using that load balancer's default target group that was created above to specify this. We then go ahead and export the URL just by concatenating HTTP to the DNS name of the load balancer. So I won't go ahead and deploy this. This takes 3 minutes or so, but what I can do is actually run Pulumi stack just to see what we've deployed here. And we can see that even though I only had to specify the load balancer and the Fargate service, underneath the hood, because this is a library that implements best practices, we're actually creating all the different resources needed to do this. From the Fargate task definition and service, to the roles and security groups, to the load balancer, target group, and listener that I need. And so this is what we mean by sort of taking those best practices, taking those same defaults, and embedding them into a really easy to use library. And of course, now I click on the link that was provisioned, and here's my Nginx container running inside AWS. So AWS X is a really nice interface. It's really Pulumi native that provides access to these features of the kind of core AWS platform. But like Joe mentioned, the AWS CDK also provides a bunch of constructs for working with at higher level with a bunch of the different AWS services. And these services are often built by teams at AWS who are defining the sort of higher level interfaces to the various pieces of their platform. And so for all kinds of different services available from AWS, we have these higher level libraries that I can go and look at and find the documentation for and start using from within my CDK applications. But with the new AWS CDK on Pulumi, we can actually go and do that in a really interesting new way. So this is an example piece of code that uses AWS CDK on Pulumi. And if I look at this code and I'm familiar with the CDK, this actually looks almost identical to a CDK program. In fact, this code here is literally just a piece of AWS CDK code. And in fact, I'm using the exact same libraries. So this is the CDK library that was provided by the CDK team. And these are the libraries for working with Lambda and event targets, events. And I'm using those within my code. The only difference is that I'm using this Pulumi CDK library, and I'm writing this within a Pulumi program. And so this Pulumi CDK library says, I want to go and deploy this Lambda stack component specified with the CDK libraries. But instead of deploying it to CloudFormation, I want to deploy it as part of this Pulumi deployment. And so if I go ahead and do that, well, I actually went ahead and did that above. It takes about a minute, so I won't just wait for it to happen. But you'll see that what happens if I go ahead and do a deployment of this program is that we have our Pulumi stack here, and inside it has a CDK stack. And that CDK stack defines a bunch of CDK constructs, but those CDK constructs themselves actually, instead of deploying CloudFormation, they deploy Pulumi resources using the AWS and AWS native providers. And this is possible because of our new AWS native provider that provides the exact same surface area as CloudFormation, but as resources in Pulumi. So you can easily take anything that targets CloudFormation and use it to build individual resources in Pulumi. What's even cooler about this is that because we're just using Pulumi to deploy this, all these resources are available and get to benefit from everything that we've got in the Pulumi Cloud Engineering Platform, including if I come over here and look at the graph view of this application, we've got all of our raw AWS resources at the bottom here, but we've also got all of our CDK constructs in our resource tree. And so the Pulumi service understands all these resources, understands what we're managing, and can run all the features it has against these, including policy as code and other features like that. So across all three of these, across the new Pulumi service provider, across the AWS X available now for all languages, and across our ability to use the AWS CDK on Pulumi, we're giving developers access to tons and tons and tons of new APIs and new things they can do across all of Pulumi's languages.
Well, that was really fun seeing the entire Pulumi platform in action, especially the inception moment with Pulumi deploying Pulumi through Pulumi with webhooks and lots of Pulumi. Love it. So let's wrap up. I just wanted to do a quick recap of what we heard today and talk a little bit about what's in store for the rest of the event today. So today, really excited to talk about universal infrastructure as code. We really are excited that Pulumi is the first platform to really embrace the full spectrum, all the way from simple things, simple, hard things possible, great programming languages, really highlighting the addition of Java support, but then also YAML with full integration in the entire Pulumi ecosystem. That ecosystem is just growing really fast. We talked about some of the community growth. I think it's just going to continue accelerating from here. We're seeing tons of practitioners and companies really building amazing things using Pulumi. You can see that in the partner ecosystem growing, over 1,000 new packages in terms of CDK interop plus Crosswalk plus folks like Oracle Cloud now integrating with Pulumi. And really all this magic powered by Crosscode, our open source cross-language technology that allows for great translation tools, multi-language sharing and reuse, everything today would not have been possible were it not for Crosscode. And, in summary, why do people love Pulumi? Well, I think, first, the universality, the fact that it can be for the entire team, for developers, infrastructure experts, security experts, and everywhere in between, folks with more of an IT ops background, folks with a coding background, a software background, everybody can really use Pulumi. The second is it's a standard workflow for any cloud. Of course, we're not going to hide what makes AWS special or Azure special, but the workflow, the way you interface with the cloud, the way that you do your deployments, manage, apply policies, that can be standardized across any cloud, public, private, or hybrid. And that's really important, especially in this modern cloud era where we're mixing, matching lots of services. We don't want to have to be doing ad hoc bash scripts to integrate, Kubernetes, kube control with Terraform, with CloudFormation, and this thing and that thing. Really, Pulumi just allows you to standardize on one thing. Third, best-in-class productivity. People that try Pulumi walk away saying, wow, this is just so much more pleasant and productive. You get more done with less time, and who doesn't love that? The four is real sharing and reuse. So we go beyond copy and paste. You can actually capture and codify best practices, whether those are industry best practices or your own organization's best practices. We don't have to copy and paste 6,000 lines of YAML every time we want a virtual private cloud. We can actually just use a real component. The fifth is really embracing this notion of cloud native, bringing the cloud closer to our application development, while also giving great software engineering tools and techniques to infrastructure. Allows you to seamlessly scale, both on the language side, going from simple YAML all the way up to full-blown programming languages, go from tens or hundreds or even thousands of resources and environments, scaling worldwide as your company and your project succeeds. And finally, just ship faster with confidence. Many of our customers say they can do in hours what used to take weeks. And that's a pretty big game changer, especially when folks want to focus on business value. Pulumi just really gets out of your way and just lets you innovate and create amazing things. And I love Floris's tweet here. This is actually multiple years ago, but sometimes something special comes along that makes you feel like you have superpowers, enables you to do more in less time, makes your work feel less involved, and ends up more robust too. Pulumi is that special thing. I just love this tweet. It's maybe my favorite tweet of all time because I think it succinctly captures everything that I was just talking about on that last slide. So thank you for joining me at the keynote. Thank you, Luke, for some amazing demos. Thank you, Brian, for sharing your thoughts on Java. Really exciting day. But we've got a lot more in store. So we've got a practitioner track and a cloud leader track. The practitioner track, we're going to go through some of the Java and YAML in a lot more depth, so you get to see the full capabilities of what we've got there. And we're going to hear from some cloud leaders on what does it mean to adopt cloud engineering, and how does Pulumi help the enterprise adopt cloud engineering at scale. We'll see from some customers talking about self-service infrastructure using automation. We'll have a couple of great panels, more of a developer practitioner-led panel, and then also a cloud leadership panel. And then I'll be back at the end to wrap things up. And so thank you so much. Everything you see today is available free. It's all open source. Go to pulumi.com/start to get started and enjoy the day. Thank you for joining me.